Did you get, or did you want a copy of the worksheet?
Oh, I don't know. Thank you.
And for coming and giving up your free time to be here, help yourself to 1 or 2 stickers out of this folder. And take them and then pass them on. And I'll start the recording. So just moving on a little bit, the last few sessions have been on trying to get, kind of more of a feel for complex power. And now I want to get a little more detailed and start working on some real problem solving and also continue to understand. So this first question I'm asking is, what is the relationship between complex power, so that's bold there, so complex power, and P and Q? And I'm not entirely sure if y'all have seen this yet or not. Well, no, you've seen this because I've shown you this. It's the next one I'm not sure if you've seen. So we know that complex power is, either of you want to tell me? P plus JQ, where P, you can either call it average power or you can call it real power. Q doesn't have extra names, it's just reactive power. And the next one is, what is the relationship between, now this is S without the boldface or the squiggle, or you could have it in absolute values. So what's the relationship between S and P and Q? So this S is the magnitude of S. It's called the apparent power. And the apparent power is the square root of P squared plus Q squared. It is also true that P equals S cosine theta. So if we have S, like the magnitude, S cosine theta, and Q equals S, it's supposed to be an S, S sine theta, where theta is the voltage angle, the phase of the voltage minus the phase of the current. And we have a special name for the cosine of theta, that's called the power factor. Now, I do something that we did a lot in power class that I don't see that your instructor does a lot in circuits too, but I find it very helpful. So if I have my real power and my reactive power, then I can make a right triangle where that's theta, and then I can get the relationship between my power, my reactive power, and my apparent power through this triangle. So when you're given the power factor, you can draw it's called the power triangle, and you can get that information. We'll talk more about the power factor in a minute. Oh, y'all didn't have class on Wednesday, so you haven't had class since I've seen you last. So you have not done power factor. Okay, so I'm just kind of introducing it so that when you see it in class, it'll make more sense. Okay. What is meant by a leading or lagging power factor? So someone asked me a question earlier, and I didn't answer because I said I wasn't sure, and I should have known because of power factor. They say, do you talk more about current leading voltage or voltage leading current or lagging? And I said, I don't know if it's one way or the other, and I should have known because when we talk about leading or lagging power factor, what we mean by that is current leading or lagging voltage? And here's why we have to say it. So let's say I have a power factor of 0.8. So what that means is that the cosine of theta is 0.8. And so theta equals the inverse cosine of 0.8. And I think the inverse cosine of 0.8 is something like 37 degrees. But, so the cosine, let me make sure I have that right. Yeah. So the cosine of 37 degrees is about 0.8, but the cosine of negative 37 degrees is also 0.8. It's like when you take the square root and you get a plus or minus answer. When I take the inverse cosine of 0.8, that is really plus or minus 37 degrees. And so when you give the power factor, you say whether it's leading or lagging to say which one it is. So we have lagging or leading. I'm going to make a little chart of the characteristics. So this means current lags voltage. This means current leads voltage. So this would be our theta I is less than theta V. This would be theta I is greater than theta V. This would mean that if we are lagging theta, which equals theta V minus theta I, theta is greater than 0, and here theta would be less than 0. So which of these is going to be inductive and which of these is going to be capacitive?
Leading is inductive.
Yeah. Leading is capacitive. Because theta is less than 0, lagging is inductive. And this would give us a Q greater than 0, and this would give us a Q less than 0. Yeah, okay. So those are the characteristics for the power factor. Okay, so here I have just some definitions so you can have for your reference. I kind of liked these. The book I got these from uses V effective instead of V RMS and I effective instead of I RMS. So whenever you see effective, that's the same as RMS. Okay. So our real power is V RMS, I RMS. So these are magnitudes. So these are not the complex values. They're just magnitudes times the cosine of theta. Or if you have just the maximum, you have the peak, the power is 1/2 V maximum, I maximum cosine theta. And then the reactive power is the same, except it's sine instead of cosine. And then the complex power is, you can look at it in all kinds of different ways. You can say it's P plus JQ. You can also say it's 1/2 V as a complex number, and then I is a complex number, but you take its conjugate, VI conjugate. Or if you're doing RMS, it's V RMS I conjugate RMS. That's your complex power. It can also be I RMS squared Z. So that comes from the same as power equals I squared R. It can also be V squared RMS over Z conjugate. And those are all complex values. And then apparent magnitude is the magnitude of the complex power. And then the real power is in watts. Reactive power is in volt amp reactive, or VAR, VAR. And apparent power or complex power is in volt amps, or VA.
What does the conjugate mean again?
Oh, good. Thank you for asking. Okay, so let's say I have V equals 20 angle 30 degrees volts, and I equals 16 angle 20 degrees amp. Then the power equals VI conjugate, which is 20 angle 30 times 16 angle negative 20. So that's one way to talk about the conjugate, is that the angle is the negative of what it is. So this will be 320 angle 10 degrees. Another way to talk about it is if I had V equals 20 plus J10 volts, and I equals 5 minus J6 amps, then VI conjugate is 20 plus J10 times 5 plus J6. And so you either change the sign of the complex part or you change the sign of the angle, and that gets you the conjugate. And this would be, I can't help myself. I think it's 40 plus J70 volt amps. Yeah, so that's what conjugate is. But thanks for asking. Okay. So we talked about power factor. This little note is just the note from the book that I got it from that said that they use effective, and that effective values are you often see them in household or industrial applications, but effective means the same as RMS. And this last one, we're not going to get to today, but if you remember about maximum power transfer, if you remember way back from Circuits 1, you had maximum power transfer when the load resistance equaled the Thevenin resistance. Well, in a complex circuit, you have maximum power transfer when the load impedance equals Z Thevenin conjugate. So when you get that gets you maximum power transfer. And then I just have this little chart with the information that we've already talked about. So any questions on any of that before we start looking at a problem? Nope. All right. So let's do our first problem. The first one is not so long, so I'll keep it on the same recording, and then I'll start a new recording for the next one. Okay, so we have a sinusoidal voltage having maximum amplitude of 625 volts is applied to the terminals as a 50 ohm resistor. Find the average power delivered to the resistor. So we're looking for average power, which is P. So P, average power or real power. And we know that P is equal to 1/2 the maximum voltage times the maximum current, or the RMS voltage times the RMS current. We also would have that P is going to equal V squared over R, because our load here is just a resistor, and so we're just looking for the real part. Now, to use this, we do need VRMS. So I think, did we have that one up here? We didn't. So you also have that P equals VRMS squared over R, but I think I gave it to you the other day. Q equals VRMS squared over X. Let's see, did I give you that? Yeah, that's right here. Very neat. And that was RMS. Okay, so we have the voltage. Do we have the RMS voltage? Not yet. We can easily get it. We have the maximum amplitude of the voltage. So VRMS, often called peak. VRMS is 625 over the square root of 2 volts. Because it's sinusoidal, you're not going to have anything that's not sinusoidal. So to get the RMS for a sinusoidal signal, you just divide by the square root of 2, and that gets 444.1.94 volts. So our power is going to equal 441.19 squared over our resistance, which is 50, and I get 3,906.25 watts. Okay. Yes, yes, yes. You could use the other equation. Yeah, there's always like multiple choices for equations. So like for part B, it says repeat A by finding first the current in the resistor. So it is also true that VRMS as whether I'm talking about complex or its magnitude is IRMS, and again, if I'm using just the magnitude, I'd use just the magnitude times Z, and again, like if it was just the magnitude. But let's do them all as complex values here. So let's say all of these are their complex values. Okay, so notice it doesn't give us an angle on the voltage, and so but they're all relative. So there's not like a set angle. You can just set one of them to be 0, and then the current either lags or leads based on that. And so since nothing is given, I can say that VRMS is 441.94. Oh, it's 94. I think I copied it wrong up here. 94. 441.94. 441.94 angle 0 equals IRMS. Now, what is Z for our circuit? It's 50, and what's its angle? It's angle 0 because it's just a resistor. And so IRMS, sorry, I needed, do I need a conjugate here? No, I don't need a conjugate here. Okay, so I equals 441.94 angle 0 over 50 angle 0, which gets me 8.838 amps. So once I have that current, then I can say that power equals IRMS times VRMS times cosine theta. And theta in this instance is 0, and the cosine of 0 is 1. So that would be 8.838 amps times 441.94 volts, which we get 3906 watts again. So we get the same answer. So I encourage you, when you are working on these problems, to try working the problems different ways. And if you have the same experience I have, when I work the problem different ways, a lot of times I don't get the same answer, and that tells me that I'm doing at least one of them wrong. And then that way I can go back and figure out where am I thinking wrong, and then that helps me learn something. So I just encourage that. So any questions before we go on to do one that has more complexity to it?